Get right into it. So, just a little bit of the review of the table. Just know what everything is. You guys have seen this before in the last lesson. Oh, sorry. And pretty much everything is just gonna be kind of built on your knowledge of this. So, just know mean is when they're asking for one quantitative, difference in mean is when they're asking for the difference in one quantitative, proportion is one categorical, difference proportion is difference in the proportional, and correlation is, the relationship. So, right in we go. All right. So, hypothesis testing. Basically, what it wants is compute the probability that a population with a specified parameter is going to produce a sample statistic similar to the one that we observed. So for this, we're going to use p-value. I'll hit this a little bit later. It's used to estimate the statistical significance. And what that is differences observed in one sample that were due to actual differences in population. Therefore, the data is valid. So this is all going to make a little bit more sense as we go. So, writing a hypothesis. So you're always going to have a null hypothesis, which basically says that there's no difference, there's no relationship, stuff like that in the population or populations. And you're going to have an alternative hypothesis, which is basically saying that there is a relationship or a difference in the populations. So 4 things that you want to know before you even set about writing a hypothesis is what's the parameter that's being tested? Is it proportion? Is it mean? Is it difference in proportions? Difference in means? That stuff is gonna help you early on. Direction of the test. So is it right-tailed, left-tailed, or non-directional? Right-tailed, it has to do with the less than or equal to sign, and non-directional. I'm gonna really just hammer this in a few examples in a bit. The value of the hypothesized parameter, so that's the number that's entered into the hypothesized statement. It's the number that they're going to be asking you about. You'll see it in problems. And just the last little thing is you're always going to have it written in terms of the population parameters because that's what you want to find. All right. So here are some examples that I think, are just some good things to get under your belt. So here's 4 different hypotheses. So for the first one, it's a difference in proportions because you have P1 and P2. It's non-directional because you have the equal sign. The value is 0 because P1 minus P2 equals 0. And it's a null hypothesis because they're saying that it's equal to each other. Next up, you've got a single proportion. It's left-tailed because it has the less than sign. The value is 0.5, and it's an alternative hypothesis because it's saying that it's something different than the value that they gave you. The next one, it's a single mean because it's got mu. Non-directional because it's got the equal sign. The value that they gave you is 0, and it's a null because it's saying equal to it. Oh, sorry. And then last one is a proportion. It's got to be right-tailed because it's a greater than sign. You've got the 0.63 that's right here, and it's alternative because it's saying it's not equal to it. So those are just a few brief examples of some stuff that you're going to have pop up. All right, so when you're writing a hypothesis, you're basically going to you're going to get the question. It's going to be, all right, so do more than 15% of American adults have a master's degree or higher? So the null is saying that it's exactly 0.15 and that, it's just that. The alternative is saying, is it more than that? So it's just simply, is it higher than 0.15? And it's going to be right-tailed because it's got the greater than sign. Oh, 1 sec, sorry. Oh. Man, you guys are so lucky. There's some kind of Penn State play going around, and it just got me bad. Oh. All right, so randomization. Basically, you're going to construct a distribution that can be used to make inferences about the population. It's going to be constructed assuming that the null hypothesis is true. You can use this distribution to find the p-value, and you can decide from it if you should reject or fail to reject the null hypothesis. So some very important things is that you are never going to accept the alternative hypothesis. never ever accept. There are going to be questions on like every single exam where it's, should you accept the null hypothesis, or accept the alternative hypothesis or something like that. If it says accept, immediately just cross out that answer choice. It's wrong. You will never accept it. And then you're always going to conclude in terms of the null hypothesis, not the alternative hypothesis. So if it ever is something about the alternative hypothesis, then you are wrong. It's always going to be a null hypothesis. So it's always going to be fail or fail to reject, or fail to reject the null hypothesis. Those are the only two answers that can ever come out of one of these. And then you're going to state it in like a real world conclusion. Why can't you accept? Because you actually don't have enough evidence to prove it. If you like think of science and all of science's hypotheses, basically, there are all these theories and hypotheses, and while we mostly accept them to be true and factual, there's always something where it's like you can't like cement it in stone, because there's always going to be some new evidence that can come up and make your observation forfeit. I was going to give you a bunch of science examples, but it's just basically like, if you think back to like gravity, originally we had this very like one-dimensional sense of gravity where it was like, we're stuck to the ground. And then Newton kind of figured, the apple comes down. And then, Einstein went and did more on it, but still that's really only for Earth. And that's, we can't entirely ever be 100% sure. So it's just like you can never accept it. I hope that kind of makes a little bit more sense. All right. So p-values. Basically, what p-values measure is how likely our sample portion is given that the null hypothesis is true. So the smaller the p-value, the more unlikely that it's going to happen. So the more significant it is. So you're always going to compare the p-value to alpha. If they don't give you an alpha, just assume it's 0.05. You're always just going to compare it to that. So if the p-value is more than the alpha, you fail to reject the evidence, the null hypothesis, because there's not enough sufficient evidence. Basically what you're saying is it still kind of fits within the null hypothesis, even if it's like really close. If it's like 0.06 or 0.051, you still fail to reject it just because it's not enough to provide sufficient evidence. And so if the p-value is less than alpha, then you can reject the null hypothesis and conclude that there is a difference in the population. I don't know why this says her, sorry. And so again, I'm just kind of like hammering this home. A p-value less than alpha is going to be statistically significant. All right, so yeah, as I said, it's a really quick lesson. If you guys have any questions, just let me know right now. We can like go back, or else, we'll just get right on into the review. Most of them are pretty straightforward questions, but the last one just kind of like something that you're probably going to see on an actual exam of like a very long question. So yeah, so I'll just start reading review number 1, and then I'll probably go get like another Hall's lozenge or something because I'm dying. All right, just to clarify. If the p-value is less than 0.05, then you reject the null. If it's greater than that, then you cannot reject the null. And they might also give you specific alpha values, where they say alpha is 0.02, 0.01, or they might say alpha is like 0.1 or something. But just like remember the value of 0.05, because that is the most common occurrence of alpha. So if you're going to say on a test, I'd say like 9 times out of 10 is going to be 0.05. All right, so this one is asking you to go back to just like identifying the parameters. So the question is, are online students more likely to pass Stat 200 than face-to-face students? So a random sample of 500 was obtained. 200 of them were taken online, 300 were taken face-to-face. And then whether or not each student passed, the course was recorded. So then which type of hypothesis test would you use to address this question? Would it be A, test for a single mean, B, test for a single proportion, Sorry. C, test for difference in means. D, test for difference in proportions. Or E, test for correlation. So let's give you guys a little bit of time to. Oh man. All right. Trying to stay healthy, guys. So the answer for this is going to be difference in proportions because really, I know like it's always going to be a little confusing what they're asking for, but it's all they're asking for is did they pass or did they fail, which makes that into a categorical variable. They really throw in like all the extra stuff, trying to like trip you up, but it just comes down to it's the proportion of the people who take it online versus the proportion of the people who take it face to face, and then what's the difference of those. So that's what it's asking for. I think I have those. So is there a relationship between high school GPA and first semester college GPA? They collected data from a sample of 100 second semester college students, asking each student what their high school and their first semester college GPA was on a scale of 0 to 4.0. So then it's which type of hypothesis test would be used to address this question. So you have the same answers, and I'll just leave you to it. Oh, all right, good. You guys got it. It is, in fact, going to be testing for correlation, just because it's asking the relationship of one compared to the relationship of the other for like the same person. So you're not really comparing two separate groups, and therefore it's going to be the correlation. All right. So next one, which of the following always contains an equality? So yeah, you just kind of have to think like what the null hypothesis really means and what the alternative hypothesis means, and Oh, all right. Give you guys a little bit of time. Yeah, you guys got it. It's always going to be the null hypothesis because it's always saying that it's like it's just that, it's, equals to whatever. The alternative hypothesis is always saying it's not equal, whether it's at literally just saying it's not equal to, greater than, or less than. It's just saying it's not the value that has previously been assigned. All right. So then, is the statement below a possible null or alternative hypothesis? There is a positive correlation between X and Y. So I'll give you guys a bit of time. So it is in fact going to be the alternative, because basically with relationships, you can't have a null hypothesis and have there be some kind of relationship. It has to simply be, it is like this. So, X is equal to Y. You can't have it be as X goes up, Y goes up. That would only be in the alternative hypothesis. That makes sense? Yeah, Mike got it. The null will always have it be equal to 0. So saying that there is like no relationship. So null is always going to be equal to 0 or equal to, like whatever, and alternative is always going to say it's not actually equal to whatever value that was assigned to it. That's the key distinguisher, is if there's like an equal sign, it's going to be a null hypothesis. All right. So yeah, that's like the kind of like iffy thing I don't really like about this chapter, is that like they could just word it in much simpler language to make it a lot easier for people to understand, but half the time, they just like go with this cryptic wording and it's just awful. So all right. Next question. A research study conducted with alpha level of 0.05. They got a p-value of 0.011. What is the correct decision? Do they either reject the null or fail to reject the null? Yep, you guys got this one. Since it's below the alpha level, you can reject the null. All right, and here is the large question I was talking about. So what it's saying is, at the beginning of the fall semester, data was collected for a representative sample of 186 students at Penn State's College of Technology. Each participant was asked the following question: in order for you to live comfortably, what would your reasonable annual salary be? You want to know if the population mean is different from 60,000. So they used the Maytab Express to create a randomized test for the single median outputs below. So assume that, yeah, if you have 0.05 alpha level, so then they just give you all this information. So you just have to, pick out the stuff that's just going to answer the question. So there are 3 questions. What is the numerical value of the p-value? Should you reject or fail to reject the null hypothesis? And is there evidence that the population mean is different from 60,000? So I'll give you guys a little bit of time to wade through this. Shoot, sorry, forget me on that one. So, yeah, you guys, you found the p-value right here, 0.023. And so because that's less than alpha, which is 0.05, that means that you can reject the null. And since you've rejected the null, that means that there is sufficient evidence that the population mean is different from 60,000. I know it's like not much different from 60,000, but there is sufficient evidence to say that you can like say it's different from, just because the p-value is smaller than 0.05. All right. So yeah, there's that. And yeah, if you reject the null, then there is evidence that says you reject the null, and there's evidence that says that the whatever you're testing for is different than the null. So if it's proportion and you're saying, oh, I think this proportion is smaller than it, and you have p0 and you have a p-value to support that, then you can reject the null, and there's evidence to support that it's less than that. Just that's kind of like what it's telling you is by rejecting it all, then you're saying that the null hypothesis is wrong, and you should instead favor the alternative hypothesis, because there's now more evidence to support the alternative hypothesis, basically because going on off a graph of the null hypothesis, basically the fact that you would get that value is so like rare that it would occur naturally, that means that it must be right. If that makes sense. All right, so that brings us to the end of the lesson. The next session is going to be the Sunday at 9. It's going to be the exact same shabam. Hopefully I won't be, sick next time. And this is going to be uploaded to YouTube. So anyone who wasn't in this session can just watch it on there if they don't want to tune in on Sunday. So, yeah, with that, that's all I got for you.